differential equation dy over dx equals y minus 1 squared cosine pi of x. On the axis provided, sketch a slope field for the given differential equation at the 9 points indicated.
So let's make our double T chart, x, y, and m. And I want to mainly focus on the first piece. So if I make y equal 1, what would all that equal? When y equals 1, all that is going to equal 0, so no matter what comes after, our slope is going to be 0 no matter what. So anywhere I see y equals 1, let's make a horizontal line. Here's y equals 1 in 3 locations. And then let's plug in, we can plug in -1, 0, 0, 0, and so on. Let's plug them in real quick. And I may show you one part of it, but not every single part. So with the partner, let's plug it in. Do 1? Okay, I'll do 1. Let's do 1, 1. So that's going to give me, a 1, 1 is silly. Didn't I say y equals 1 is what's going to give us a horizontal? Instead of 1, 1, what can we test? 1, 2. Is there a 1, 2 here?
1, 0.
1, 0. Let's do that. So we have 0 minus 1 all squared, cosine of pi times 0. We know all this is going to give me 1. Now cosine of 0 is going to give me at 0 pi. Our order pair is 1, 0. Isn't that basically 1? All of that is equal to 1. So our slope is positive 1. And the positive 1 slope looks like, which one was it? 1, 1, 0 right here. Was it a positive slope though? I have a negative slope for some reason. Let me double check. Cosine of 0, 1, 0. Oh, I see what happened. What was I supposed to plug in into this one? The x. Wasn't that pi x? So pi x, meaning our x on this one was 1. So then it doesn't make sense for it to be negative then. So at pi, the order pair is -1, 0. And when I do, we get -1 is at pi for the cosine. So that is -1. Oh, silly. So let's go ahead and make that graph going downward. So are we okay with that idea though? Okay? So as you follow the pattern, it's going to look like the following. A little bit steeper. So any part of this you guys want me to show, I will, but it's basically plugging in x and y, okay? So on part B, Luke, go ahead and read.
There is a horizontal line with the equation y equals c that satisfies this differential equation. Find the value of c.
So we did make a horizontal line when we had y equals 1. So let's write out that piece will be y equals 1. And it says y is equivalent to c, so we know our c value should be also 1. We okay with that one? That one was really easy. So I feel like these two parts, for sure on the AP test, do not miss. All right, the last part. Hannah, let's read part C.
Find the particular solution y equals f of x to the differential equation with the initial condition f of 1 equals 0.
All right, so what we're basically doing is we're taking this and we're gonna put all the y's together and all the x's together, okay? So I want you guys to kind of think about this. We are first going to multiply by dx on both sides. Do we see that? Because I'm gonna skip some steps. And then we're gonna divide it by y minus 1 all squared. Do we see that too? Now the way I'm gonna write that out is y minus 1 on the top with a -2. So it's gonna look like the following. Y minus 1 to the -2 dy is equal to cosine of pi x dx. So I moved the dx on both sides and then moved the y minus 1 all squared and then brought it to the top. Okay? So then let's go ahead and integrate. So let's do a quick practice on integration. We need our u substitution here. So off to the side, we have u is equal to y minus 2. Then that gives me du is equal to dy. What's that? Oh, dang it. My seniors are still here. That's amazing. All right, there's still hope, right? So let's go ahead and plug it in. We have integral of u to the negative 2 du. And let's go ahead and integrate the other side while we're at it. So we know our u is equal to pi x. Du is equal to pi dx. And what do I need to do with the pi since I don't see it on the original? Divide. So 1 over pi du is equal to dx. So I have the integral, and I'm going to kick out the 1 over pi. We have cosine u du. Okay, good so far? So now let's go ahead and integrate. When I integrate the next piece, that's going to give me 1 over, what is 1 more of that? Power. Negative 1. U to the negative 1. And I know we need plus c here. Since I'm going to add plus c on the other side, I'm just going to save that piece. Is equal to, leave the constant. What is the antiderivative of cosine? Sine. So we have sine of u, and then let's write plus c one time here. So if I were to simplify this, really in the end I get negative 1 all over. By replacing this, we have y minus, for some reason I have y minus 2. Okay, should be y minus 1. And then let's go ahead and replace the other one as well. 1 over pi, sine of pi x. And then plus c. So let's worry about plugging the numbers in. What numbers did it say to plug in? 1 and 0. So here's my x, here's my y. So when I plug it in, I get negative 1 over 0 minus the 1 is equal to 1 over pi. Sine of 1. So 1 pi plus c. So let's see what the sine of 1 pi is going to be at. At this spot, is there an opposite movement? So we know all this is going to equal how many? 0. So we could then say c is equal to how many then?
1.
C is equal to 1. Do I need the c on this one? Yeah. So we know our c is equal to 1. So let's bring this one back here and plug everything back in. So we have negative 1 over y minus the 1 is equal to 1 over pi, sine of pi x, and then plus 1. So then we need to solve for y. And let's see if y'all remember the rule from maybe back in geometry. If you were in my pre-cal last year, we talked about this. Since I need to make y by itself, am I allowed to swap the bottom to the other side? Does that sound kind of new? Okay, I'm going to go ahead and write something on the side. I want you to write out a over b is equal to c. And if I were to ask you to solve for b by itself, you may swap the denominator and the other side. So we get a over c is equal to b. And that's basically what we're doing on this one. So when I do, we get the following. We get negative 1 all over all that component. Is equal to y plus 1, or y minus 1. And look at our last step. All I need to do to make y by itself is do what on both sides? Add 1. So I'm going to steal this room right here. And it's gonna look pretty fancy and it's perfectly fine. And then plus 1, and that's our final. Ooh, y'all can't see it. All right, now let's go on to number 14 then. Oh, 13, that's right. Okay, on number 13, are we good with this? Okay. Are we writing okay in the back? Okay. On number 13, Edith, let's read.
At the beginning of 2010, a landfill contained 1,400 tons of solid waste. The increase in function W models the total amount of solid waste stored at the landfill. Please estimate that W will satisfy the differential equation dW over dt equals 1/25 W minus 300 for the next 20 years. W is measured in tons and T is measured in years from the start of 2010.
And the question?
Find the particular solution W equals WT to the differential equation dW over dt equals 1/25 W minus 300 with the initial condition W of 0 equals 1,400.
Thank you. So let's look at the equation. So the first thing we're going to do is multiply by dt on both sides. Yes? What else am I going to move so all the letters are together? W minus 300. So let's write it on the top right here. Well, for me on the top. If y'all can fit it on the bottom, please do so. And then we have dW is equal to, then 1/25 dt. Are we okay with how I organize it? And then we want to integrate. So let's do a recall. If the integration of 1/x is natural log of x, integration of the first one must be?
Natural log of W minus 3.
And we need the absolute value because in the natural log, it cannot compute a negative number. But once the natural log goes away pretty soon in a little bit, we'll get rid of the absolute value. And let's do plus c on the other side only. So we have for 1/25, that's considered a constant.
Natural log of,
Oh, there's no x here.
sorry.
1/25 t plus c. It's kind of like saying if I give you 5, then the antiderivative is 5x. So if I give you 1/25, 1/25t. Okay? So we need to solve for w, or solve for w basically. So what can I do to get rid of my natural log?
Do the E thing.
Yes. And raise everything e to the power of what I have existing. So we know that's going to cancel out. And since natural log is gone, what can I take out?
W minus 300.
The natural log can be taken out. So another way to rewrite this one would be the following. E to the power of 1/25t times e to the power of c. Because when you have exponents that are added, it is multiplied with the bases. And then another way, or a better way to rewrite this, I think I'm going to write it over here now, is going to be w minus 300 is equal to c. It's going to replace all of this. Because e is a number, c is a number, why not make it a one clear variable as our c for the number? Then we have e to the power of, oh, why did I change my color right here? Oops, 25t. So is my w almost by itself?
Just about.
What do I need to do on both sides?
Add 300.
Add the 300 plus 300. So now we know two things. It says when the domain is 0, the range is 1400. Let's plug it in. So 1400 is equal to, since all of this is going to be 0, what is e to the power of 0?
1.
1. So why not go ahead and say c plus 300? Then what is my c? 1100. So our final answer is going to be W is equal to, and we're going to replace the C with 1100, e to the power of 1 over 25t. And then we know our C value is what? Not the C value, but the number by itself is 300. So basically what I did was I went from here to here.